In the early 1900s, Ernest Rutherford and his assistants used alpha particles to discover the nucleus. Alpha particles are helium atoms with a +2 charge and are produced when uranium or other radioactive elements decay. Rutherford's team directed a beam of alpha particles at a thin gold foil. The alpha particle source consisted of a radioactive substance in a lead box. A small hole was cut in the box so that the alpha particles would shoot out. Encircling the foil, except for a small slit for the alpha particles, was a strip of screen coated with zinc sulfide. As the alpha particles hit the zinc sulfide, a flash of light was produced. Until Rutherford's experiment, it was thought that the atom was composed of a sphere of positively charged matter with tiny negatively charged electrons embedded in it. This model was proposed by J.J. Thomson in the early 1900s and was called the plum pudding model. He reasoned that it was like pudding with raisins in it. If Thomson's model of the atom were correct, Rutherford's alpha particles would either go directly through the foil or be deflected very slightly. Remember, the alpha particles are large energetic particles, while the electrons were thought to be very tiny particles, and the positive matter took up much more space than the electrons. Rutherford's team did see this behavior, but they also observed particles being deflected at large angles, with some particles deflected almost directly back to the source. On the basis of these results, Rutherford was able to come up with a new model for the atom. He reasoned that almost all of the mass of an atom is located in a very dense, very small center called the nucleus. He postulated that this nucleus contains all of the positive charge of an atom, and that most of the atom's volume is actually empty space with electrons traveling around the small nucleus. The researchers saw deflections at large angles, even straight back, because some of the alpha particles, which are positively charged, would come very close or even hit a positively charged nucleus and be deflected. And most of the particles went straight through because they encountered empty space. Rutherford's model is still accepted today, although scientists later discovered that the nucleus contains positively charged protons and neutral neutrons.